Good morning students. Today in this video we will see some more special models of integration. Please listen. To integrate integrands of this type, integral 1 divided by px plus q into root over ax plus b into dx. This is number 1. To integrate this type of integrands, or integral ax plus b, that is root over ax plus b divided by px plus q into dx, or integral px plus q divided by root over ax plus b into dx, or integral px plus q into root over ax plus b into dx. To integrate this type of integrands, you please see these. These are 4 different models, but they are similar models. All the 4, they contain linear factors. One linear factor in the square root, other without square root. See, px plus q. What is this? It is a linear factor. This is also linear. One is in the root and one is without root. See, same. So if this type of integrands are given, how to solve this? How to find the integrals of these? There is a procedure for all the 4. For all the 4, what is the procedure? Very simple. So which linear factor is inside the root? Ax plus b. Ax plus b. Therefore our substitution is, you suppose root over ax plus b is equal to t, or this is nothing but ax plus b is equal to t square. Both are same. So therefore for this type of integrands, what is the substitution? Substitution is this. Root over ax plus b is equal to t. This is nothing but ax plus b, the linear factor which is inside the root. You suppose that factor equal to t square. By taking this substitution, simply you proceed. You will get the integrand in standard model, then you can write its integral. Okay, this is the way of finding integrals for these 4 types of integrands. This is the substitution. Now we will discuss some examples. For all the 4, I will discuss one example. We will see that. Okay. Yes, please see. To find this integral value, this is exactly 1 divided by 2x plus 3 into this. This is of this type. Just now we have seen for all the 4 what is the substitution. This value which is in the root over 4x plus 5. You suppose this as t. Then this is nothing but 4x plus 5 is equal to t square. Both are same. This is our substitution. From this differentiating 4 into dx, 5 derivative is 0. What is t square derivative? On the right side t square is there. It is 2t dt. Therefore, from this dx is equal to this 4 divides here. That means t by 2 into dt. Okay. What is this? This is substitution method, also known as change of variable. So we have taken this as t. Dx is also obtained in t. What about this? This has to be transformed to t. Therefore, by taking the substitution, what is there here? 2x plus 3. I should get 2x plus 3 in terms of t from the substitution. See Nana, 4x is equal to t square minus 5. I want 2x plus 3, no? So therefore I will write 2x is equal to t square minus 5 divided by 2. We need 2x plus 3, therefore adding 3 on both sides. T minus 5 by 2 plus 3. What is this? If I take LCM, LCM is 2, here 6 will be coming. Therefore, this is t square plus 1 by 2. Therefore, very simple. With this substitution, the given integral becomes 1 divided by, what is 2x plus 3? 2x plus 3 is t square plus 1 divided by 2. That I can write here. What is this? Root over 4x plus 5. It's a substitution. It is t. What is dx? Dx is t divided by 2 into dt. Therefore, I can cut t and t, 2 and t. 2 of course. So finally, what is there? 1 divided by t square minus 1 into dt. See how simple it is. It is one among our 47 formulas. Very simple. It is 1 by 1 plus x square or x square plus 1. It has a standard integral. What is it? It is tan inverse of t. That's all. Plus c. Therefore, tan inverse of t is not given in the question. Replace it by x. According to that substitution, what is t? It is root over 4x plus 5 plus c. This is the answer. For all the 4 models, this is the procedure. Okay, this next example. Next problem. Integral 2x plus 3 divided by this. Both are linear. It is of which type? This model. For all the 4, same procedure only. So therefore, what is our substitution? 4x plus 3 root over 4x plus 3 is equal to t. This is nothing but 4x plus 3 is equal to t square. Okay? Yes. Now what about this? Differentiating this, 4 into dx is equal to 2t dt. From this, what is dx? Dx is equal to t by 2 into dt. Also here 2x plus 3 is there. Therefore, from the substitution, I will write 4x is equal to t square minus 3. I need 2x plus 3. Therefore, I will take 2 here and I will write it on right side. So we need 2x plus 3. Therefore, adding plus 3. T square minus 3 by 2 plus 3. What will be this? If I take LCM 6, no? Therefore, t square minus 3 plus 6 is plus 3 divided by 2. Therefore, substitution is change of variable. 2x plus 3 is there. In place of 2x plus 3, I can write t square plus 3 divided by 2 into, what is this? Root over 4x plus 3. According to substitution, it is t. What is dx? Dx is t by 2 into dt. So I can cut t and t here. So in the denominator 1 by 4 is constant. I write outside. What will be there? T square plus 3 only into dt. Yes, this is what 1 by 4 into. You can differentiate both separately. For first one you should use what? X power n. Therefore n plus 1 by n plus 1. Only 3 is there. 3 is a constant. 3 is 3 into 1. 1 integral is x, but here variable is 3, no? Therefore it is 3t plus c. In the question t is not given, therefore I am writing here. From this and this I can take t common. If I take t common, I will be having here t square plus 3. Of course, by 3 is there, here it is 4 plus c. Okay, if I take LCM, now this becomes t into t square plus 9 divided by 12 plus c. Now we will replace t. What is t? T is root over 4x plus 3 into t square. This is t square. T square plus 9. If I write 9 here, 4x plus 3 plus 9 is 12. Divided by 12 is there plus c. If you want, you can take 4 common here. If you take 4 common, you will have x plus 3 into 4x plus 3. I took 4 common in the numerator, that will be cancelled 3 times. Plus c. This is the answer. See another integral. This is linear, this is also linear. It is of which type? This type. Substitution for all the 4 same. Okay. Now what is our procedure? We should suppose this value which is inside the root, including root, you suppose this is t. This is nothing but x plus 1 is equal to t square. If I differentiate, dx is equal to 2t into dt. Also x plus 2 is there now. Therefore from this is x plus 1. I will add 1 on both sides. Obtained x plus 2. Very simple. Therefore this is integral. What is x plus 2? It is t square plus 1. What about this? This is t. What about dx? Dx is 2t dt. Yes. So 2 is constant. I can write outside the integral. Then t into t square. You multiply with this. It will be t power 4 plus t square into dt. Simple integral. If you integrate this using x power n, this will be x power t power 5 by 5 and this is t cube by 3 plus c will be there. Here I can take t cube common. I will write outside. Then what will be there? T square by 5 and 1 by 3 plus c. Okay, one more step. This is equal to 2t cube into. If I take LCM, I will be getting 3t square plus 5. What is LCM? 15 plus c. Yes, now we will substitute t value. We will obtain in terms of x. See carefully. What is this? 2 by 15 is constant. T cube. This is t. T means what? T is x plus 1 whole power. Root means 1 by 2. t cube means 3 by 2. Therefore, it is x plus 1 whole power 3 by 2. And what about this factor 3t square? This is t square. 3t square means 3x plus 3. Plus 5 is there, no? Plus 5. What this factor becomes? 3x plus 8 plus c. That's all. This is the answer. So these four are of one type. So in the previous video we have seen three different types which depend on ax square plus bx plus c. Now these are all the four same model, same of course. They depend on two linear factors. One is inside the root, one is without root. For all the four, same substitution. Yes.